Okay, let's talk about the dermis. So what I'm going to do here is I'm going to draw the dividing line between the dermis and the epidermis. So this isn't the outside environment. This here is going to be the epidermis, and that's going to be superficial. And this, anything I draw down below this line, is going to be the dermis. Let's also add in some of our hypodermis. Right, so here's our adipocytes down here, indicating the deeper border of, you can spell hypodermis any way you want, but indicating the deeper border of the dermis. Oh, and then also let's note, as you would go deeper, you would hit muscle, and then eventually you would hit bone. Okay, so two things to know is that there are two blood vessel plexuses that run throughout the dermis. And we're going to put those in first because it's important to note these. There's a blood vessel plexus that runs here and puts like little coils of availability up into each of these ridges, which each of these ridges is called a dermal papilla. I know you're like, Amy, I thought those were epidermal ridges. Yes, right? Yes, if you're going to refer to the epidermis, we would call these epidermal ridges. If you're going to refer to the dermis, we call these dermal papilla. Sorry, it's just the frame of reference, that's all. Don't forget that any blood plexus not only has arteries, but also has veins. And so this plexus here, this is what is called the subpapillary plexus. So subpapillary indicates its location, that it's deep to the papillary layer of the dermis, which we'll draw in a moment, or deep to the papilla. And this one, there is another blood vessel delivery, and that one's down here. And that one has some coils up into the dermis a little bit, not so much though. And this one down here is called the cutaneous plexus. I have seen this one referred to in the past as just the subcutaneous plexus, but your book and other books refers to it as the cutaneous plexus. Now, you would burn away the subpapillary plexus in a first-degree burn. I mean, in a second-degree burn, definitely. You've probably burned some of it in a first-degree burn. The cutaneous is burned in a third-degree or a full-thickness burn. And the problem with this is that once you remove the subpapillary and the cutaneous plexus, there's no longer glucose and oxygen delivery to the tissue, and therefore it's not going to be able to heal itself. The subpapillary plexus, though, provides a really good dividing line for us. And so the dermis itself is divided into what's called the papillary layer, which is only about 20% of the dermis. So I guess I didn't draw the proportion that great here. But the papillary layer is full of areolar tissue. And remember, the papillary layer is like a structure of the skin. It's a sublayer of the dermis. And areolar connective tissue is the type of connective tissue that's present. Remember, connective tissue is one of the 4 types of tissue. And in connective tissue, we have collagen bundles. They're spaced far apart. In connective tissue, we also have elastic fibers, and we also have reticular fibers. So we pretty much have everything in areolar tissue. And areolar tissue, honestly, it's like packing tissue. It's like, what do we put in here? Areolar. Deep to the subpapillary plexus, and between the cutaneous and subpapillary plexus, is called the reticular layer. And this takes up about 80% of your dermis. And the reticular layer is full of a connective tissue called dense irregular. Dense irregular is categorized by these collagen bundles. And they don't run parallel to each other. They're just kind of arranged in completely random configuration. And these collagen bundles, they bind water. Their ability to bind water declines as your life increases. And this is why it's really important to take care of your skin, right? Because if your dermis, which is like a gelatinous body stocking, if your dermis starts to dry out, that's where a lot of the water in your body is stored. But also if your dermis starts to dry out, it means the organ with your most surface area is starting to suffer. There are some elastic tissues in dense irregular tissue, and there are tons of different types of cells. The most common type of cell that you'll see in dense irregular are kind of star-shaped, and they're called fibroblasts, which make the collagen and elastin fibers. Once they start to switch over to not making but maintaining them, we call them fibrocytes. There are also these big, huge cells with these vesicles in them, and every once in a while these cells can be provoked to release their vesicles. These cells here are called mast cells. They're actually part of your immune system, and what they're releasing is histamine. Yes, these mast cells respond in an allergy, but you'd be surprised at how many things they can actually respond to. And then there's these big cells that, no joke, kind of look like Pac-Man. And these are called macrophages. And what these do is they move through the dense irregular connective tissue, kind of like a policeman walking the beat, right? And when they sense a pathogen, they'll engulf the pathogen and then kind of like notify other immune cells saying, hey, I found this. Do you know what it is? Do you know how we fight it? And the lymphocyte will be like, I do. Thank you for bringing this to my attention. Okay, so the dermis is what we call vascularized, whereas the epidermis was not. And the dermis is vascularized because it has these blood vessels, right? It's got the subpapillary plexus and the cutaneous plexus. Now, what happens is that oxygen diffuses out. Oh my gosh, to reference chapter 3, simple diffusion moves oxygen superiorly. And the oxygen moves into the epidermis, but as the oxygen moves further and further from its origin, the blood vessels, it starts to kind of lose momentum, and it also gets consumed. And the extent of oxygen into the epidermis, the extent to which it can move, determines that borderline of the live and dead cells. And as I've been drawing and reminding you that the epidermis seems to have this layer that's deep in it, and it's this layer that everybody always thinks is the borderline between the dermis and the epidermis, right? Remember, I keep saying that everybody thinks this is the borderline. That is not. This is the borderline right here. And the thing is that this borderline contains the alive cells in it. And it's these cells that are receiving the oxygen from the subpapillary plexus. As those cells move superiorly, they lose access to the oxygen and also the glucose. So oxygen and glucose are two things that your cells need to make ATP. And this is why oxygen and glucose, despite everything that can be held in blood, oxygen and glucose are the most important to think about.